Recording, right. On to question 3 now, the Doppler effect. A nice leading title for the question. When the Doppler effect occurs, it is known that the apparent frequency of sound is increased as the source of sound moves to a stationary observer. Here's my observer, here's the source of sound, you know, the famous ambulance siren. Here come our wavefronts, and so forth. As the ambulance moves, you know, each wavefront is emitted that bit closer, and so forth. Explain why the frequency increase occurs. Right, I'm halfway through that. I think that diagram is a good one to start with. So let's just draw it like this. So t equals 0, let's say a wavefront is emitted. I would say wave moves at speed c. That's usually the symbol we use for wave. So at t equals some time in the future, let's call it capital T. So our wavefront has moved that distance there, velocity times time. Our ambulance, on the other hand, has also moved. It's moved v times t, and if t is the time between wavefronts, so the period of wave, so we say next wavefront. We can see the two wavefronts are, the wavefront is there. We've got our source on the front of the ambulance. The wavefront is there. So we can see that the wavelength that distance minus that distance equals c minus b t, which is less than ct, which equals c over frequency, which equals the wavelength for stationary. So I think diagram really good, and then I'd say in the text, since the source moves, a wavefront is emitted closer to the previous than would be for a stationary object. So that implies the wavelength is reduced, implies that frequency is increased. Words to that effect, but I think the diagram is really powerful to show that you know what you're talking about.